My name is Iida. I'm a professor at the Tokyo University of Science. My area of focus is solid-state thermoelectric energy conversion technology and applications. Currently, we are developing environmentally benign thermoelectric material and an automotive waste heat recovery system. Consider the massive amount of fossil fuels that we consume as a primary source of energy. Of this, about 70% is discarded as waste heat. If oil use increases, if carbon dioxide emissions increase, and if we don't concern ourselves about climate change, then biological diversity will decrease significantly with unknown ecological consequences. In fact, around 100 species go extinct each day. 100. I know this figure is so high that it is hard to believe. Reducing carbon dioxide emission to minimize the resulting warming due to the greenhouse effect will be crucial. To achieve this, we will need to get away from the present pattern of consuming fossil fuels such as coal and petroleum, and shift to adopting renewable energy sources such as solar cell and fuel cell powered by water split hydrogen. We believe that nuclear power is not a sustainable alternative because of the radioactive waste generated and limited uranium reserves. You may likely know, following the March 11, 2011 earthquake, there was a hydrogen explosion at the Fukushima nuclear power plant. This was mainly due to the colossal natural disaster, and since then, the surrounding area had suffered from radiation emitted from the plant. At the same time, since we can't quit using fossil fuels immediately, proactively looking to make use of waste heat is an urgent topic. This is an approach that is needed to help sustain the huge and growing energy consumption taking place worldwide. The ongoing rise in energy consumption can and will profoundly influence our environment and our lifestyles. This much is clear. A good example is the automotive industry. By 2020, experts forecast that the production of combustion engine vehicles will reach 100 million units. In the case of typical passenger car, fuel efficiency is less than 25% when driving. In other words, more than 70% of the fuel used is emitted as waste heat. Currently, we are developing an automotive waste heat recovery system using environmentally benign thermoelectric materials. We believe that this thermoelectric power generation technique can be an important solution to reduce carbon dioxide emission from automobiles. Now, you might ask why we want to use thermoelectric power generation in cars. In short, the reason is because automobiles are highly scalable, the system integration is easy, and it offers great scope for reducing fuel consumption. In my lab, like elsewhere at TUS, we are undertaking research that will hopefully lead to applications that make the world a better place for tomorrow's children.